Our next lesson is called Distributive Property and Combining Like Terms, Day 2. So if you think back to the previous lesson, we spent some time reviewing some vocabulary. We know we have variable terms, which are terms with a variable. From those, you find coefficients. Coefficients are the numbers next to the variable or in front of the variable. And we also learned that constants are terms without variables. So they're just basically another name for numbers. We also reviewed the distributive property. Remember, distribute means to give. So you're going to give everything that's on the outside of the parentheses to everything inside using multiplication. And lastly, we reviewed how to combine like terms. Anything that is considered a like term should be combined by combining those coefficients or adding or subtracting those numbers. Today, we want to put those two things together. There are going to be expressions that need to be simplified that are going to have parentheses, so that means distributive property is going to have to be used, and there will be like terms that can be combined. So we want to make sure we understand the proper procedure, what comes first, what comes second, and I'll show you a few examples and how these questions might look. So one thing to remember when you're doing a problem that has distributive property and combining like terms is that we still want to follow the order of operations. PEMDAS, right? Parentheses, exponents, multiplication or division, whichever comes first, and then addition or subtraction, whichever comes first. What's important to us there is multiplication and addition. Multiplication comes before addition in the order of operations. So that means when we're simplifying expressions, we have to distribute first because distributive property is multiplying, and we have to combine our like terms second because that's the part where we're adding. So it says to simplify an expression means to ensure there are no parentheses and no like terms in your final answer. In order to do this, we want to distribute first. So highlight this or underline it, whatever you choose. And then I also want you to put a number 1 by it, showing that's the first thing that should be done. Then we want to combine like terms. And we're going to label that as number 2. Sometimes in the directions, you might see this called simplifying completely. So I want to make sure you understand that's the same thing. Simplify the expression or simplifying completely. Your answer should have no parentheses and no like terms. That's how you know you're at the end. So let's look at our first example, and I'm going to continue to color code just to help you out. Anything that has something outside with a set of parentheses next to it should set off an alarm that that is distributive property. So the 3 has to be distributed through this set of parentheses, and the 2 should be distributed through the second set of parentheses. So we're going to always do distributive property first. 3 times 2t would be 6t. 3 times 5 would be 15. 2 times t would be positive 2t. And 2 times negative 5 would be negative 10. Then as step 2, now that the multiplication is done, we want to see if there are like terms that could be combined. So I see 6t and 2t, that would be considered like terms. And I see 15 and negative 10. So 6t and 2t would be 8t. 15 and negative 10, or 15 subtract 10, would be 5, positive 5. So that is our final answer. I don't see any parentheses, and I don't see any like terms. And now you can see the order in which they should have been done. Now in our second example, there's something different going on that we want to point out, and I'll be able to do it in these next 2 examples. I'm actually going to take this expression and rewrite it, and there's a couple key things, well, one key thing I need to add in. So 10, subtract. Now, I see a set of parentheses, and it almost looks like there's no number in front. But hopefully remember, when we don't see a number there, there's really a 1. So I'm going to write the 1 in there so that you can see it. And all I did was rewrite the expression, filling in that gap with the number that is really there. There's really a negative 1 in front of that set of parentheses in the middle. So -1 has to be distributed to y minus 6. So I'm going to copy the 10 down. I am not doing 10 minus 1 first. Multiplication comes before subtraction in order of operations. So the 10 just gets copied. We're not doing anything with that. We're taking the -1 and timesing it by y. So that would be -y or -1y if you want to write the 1 in. And then -1 times -6 would be +6. Now is when we'll do all of our adding and subtracting or combining of like terms. So I see a 10 and a 6, they would be like terms. And I see -1y and another -y or -1y if that helps you to write the 1 in. So I have 10 and 6, which is 16. I have -1y and I'm adding it to another -1y, so that'd be -2y. So there's my final answer, no parentheses, no like terms. So now let's kind of take all of that and do our most difficult one, which puts all of that stuff together. Don't get overwhelmed, go piece by piece. So first, I'm going to rewrite this 6 plus 8 times 4w minus 7. And there's another one of those spots again where I don't just have a negative, I really have a -1 times 2w plus 1. Now, if you don't want to rewrite it, you could just write it in the original problem. I'm really just kind of spelling it out for you on here because it is your notes and it's the one time you're going to hear this reminder and an instruction. So you do whatever works best for you. So now I can go ahead and take care of all my distributive properties. Once again, distributive property has to happen first because it's multiplication. So I should not be doing 6 plus 8 makes 14. That would be incorrect. I should be taking the 8 and multiplying it through to 4w minus 7. And I should be taking the -1 and multiplying it through to 2w plus 1. And notice how I take the signs with the number. So the 6 is just getting copied. I didn't do anything with it yet. 8 times 4w would be 32w. 8 times -7 would be -56. -1 times 2w is -2w, and -1 times 1 is -1. So now we can go through and find our like terms. I see 6 and -56 and -1 as like terms. And then I see 32w and -2w. Always taking the signs with it so I know whether they're positive or negative. So 6 take away 56 would be -50. Take away another 1 would be -51. And 32w minus 2w would be 30w. So plus 30w. And then I see no parentheses. I see no like terms. So I know I've simplified it all the way down completely. Now remember from the previous lesson, you can write the 30w first, minus 51 second. The order does not matter. I also tried to do what we talked about in the previous lesson, that it doesn't matter how you code your like terms. Lines, squiggles, circles, double underlines, boxes. You do whatever you have to do. The important part is coding to find out what's alike. So one last application of having to have an expression where you have to distribute and combine would be how it's used in geometry. In math this year, we will do algebra and we will do geometry. So here's a spot where they collide. Geometric applications. It says write down the correct formula. So you're going to decide that based on whatever shape's in front of you. Substitute into the formula what you know. And then simplify the expression completely, which we just talked about. Make sure you distribute, then combine like terms to get your final answer. It says, very important, you are not going to get a number answer. Your answer should be an expression. That is something I know that you're getting used to. So we're going to do one example of this, but I'm going to show you two different methods. So give the perimeter. That's the key word here that we want to kind of point out. We need to know what perimeter is. of the figure as a simplified expression. So that means no parentheses and no like terms in our final answer. So first, let's look at this. It's a rectangle. So important to kind of fill in the rest of the labels. Opposite sides are the same. So if this side is y plus 2, this side is also y plus 2. And if this side is 3y minus 5, then this side is also 3y minus 5. That's the property of a rectangle. Now, why is that important to us? Because we have to find the perimeter. Do you remember what perimeter is? You learned perimeter, you learned area. Take a second to think about that. What is perimeter? Well, there's two ways you can think of this. Method one is just maybe how you remember it. I remember perimeter like fencing. If I'm going to fence in my yard, I have to find the distance all the way around my yard. Perimeter is when you add up the distance around the outside of the figure. So the way you might write this is that P equals adding all sides. What I like about remembering it this way is that perimeter is the same for all shapes. So if you don't remember the formula, if you can at least remember perimeters adding up all the things, then you can still find your answer what the perimeter is. So if I did it this way, I would put P equals, and I would just write down all the expressions and put plus signs between them. I want y plus 2. I'm going to add to that 3y minus 5. I'm going to add to that y plus 2. And I'm going to add to that 3y minus 5. I'm just adding up everything around the outside. Then I can go through and find my like terms. So I have y, 3y, y, 3y. And then I have 2, negative 5, 2, negative 5. So now all I have to do is add up my like terms. My perimeter is y plus 3y, which is 4y, plus y is 5y, plus 3y would be 8y. And then I add up 2 and negative 5, which would be negative 3, plus 2 would be negative 1, minus 5 would be negative 6. So the perimeter for my figure is 8y minus 6. Notice that once I realized what perimeter was and I wrote down adding everything up, it was using skills we already had. In this case, I didn't have to do distributive property because there were no parentheses. I was just able to add up the like terms. Now in method 2, this is kind of referring to this first bullet point, write down the correct formula. I personally like to use the formula because it's just a little bit less writing. The formula for the perimeter of a rectangle gets at the point that there are two 3y minus 5s and there are two y plus 2s. In any rectangle, you can get the perimeter by adding up, we'll switch colors here just so you can follow, twice the length plus twice the width. So when I plug this in, I get P equals 2 times the length, our length was 3y minus 5, and plus 2 times the width, our width was y plus 2. So it's a little less writing, and it's just a different way to look at it. 2 lengths added up to 2 widths. So here I get to show you the application of what we're talking about today. First, we want to make sure we do the distributive property. 2 goes through this set of parentheses, and then 2 goes through this set of parentheses. So we get perimeter equals 2 times 3y would be 6y, 2 times negative 5 is negative 10, 2 times y is 2y, and 2 times 2 is 4. And then as my second step, I will find my like terms, 6y and 2y, negative 10, positive 4, and I will combine them. So my perimeter is 6y plus 2y is 8y. And negative 10 plus 4 is negative 6. So my final answer, again, is the perimeter is 8y minus 6. You see, I get the same answer no matter which way I do it. So there are options for how you do this with geometric applications. And of course, it's going to depend on what your shape looks like. So at this point, we have learned them all separately. And today we were able to show you how to simplify an expression by distributing and combining like terms. And now we also see how this could show up in some of our geometry problems. And that concludes our lesson on distributive property and combining like terms, day 2.